state-of-the-art quantum computer chip. The company claims Willow leapfrogs over the supercomputers that we used to consider the world's fastest, and it takes 5 minutes for them to solve a problem that would currently take supercomputers 10 septillion years to complete. Well, Professor Alan Woodward is a computer scientist at Surrey University. Septillion, before I ask you how much is that, I know it's a lot. But first of all, I'm going to start with the very basic question. If you can explain what a quantum computer chip is.
Right, that's the $1,000,000 question. In conventional computers, the laptop I've got in front of me, the unit of information that's used for processing is called a bit. Most people have heard of a bit, and it has two possible values, 0 and 1. And typically the way they're implemented on a chip is with a transistor, which is a fancy switch, so the switch is either on or off. So it's either 0 or 1. In quantum computing, you use what's called a quantum bit, and the quantum bit can also be 0 or 1. But if you can coax it into this very special state, it's a complex combination of 0 and 1. Some people argue that it's all possible values at the same time between 0 and 1. And if you get lots of those working together, then you can actually, it turns out there's some algorithms you can do which are much faster in that sort of state with a qubit than you could ever do on a conventional computer. I'm slightly hesitant to say that this is the comparison with the supercomputer is actually really a valid one, because the algorithm they implemented is really all about, it relies on quantum physics. And so the first thing the supercomputer would have to do is simulate the quantum computer or the quantum circuit. So I'm not sure it's a fair comparison in some ways. But the more interesting part about what they've done, what Google have done in this paper they've put out, is what's called error correction, which is a very boring subject. Most people will never have heard of it, but we're all relying on it. I'm using it right now. All our modern electronics have errors in them all the time. And if you're not to end up with just lots of noise, but actually a signal you can use, you have to do what's called error correction. And what they've worked out is how to build a chip with over 100 qubits on it, such that they've reduced the error rate below a magical threshold that everybody's been trying to get to for a long, long time. And that's the big breakthrough, if you like. So I hesitate to say it's a breakthrough. I think it's probably more of a major milestone, and it's certainly very encouraging for anybody that's working on quantum computers, because it means that what we can do is we now know we can scale these things up. We can add more and more qubits to the chips without necessarily just incurring a consequentially larger number of errors.